Hello students, welcome to Creata Classes. I am Gurmeet Singh and also welcome to complete series on chapter Circle for class 10 students. We will cover all these lectures in this series using the power of visualization and animation. And especially in this lecture, we will cover exercise 10.2 question number 1 to 5. We have divided the complete exercise into the 3 parts. The link to other lectures is given in the description. Check it out. So without taking any further time, let's start with this lecture. Let's take the question number 1. From a point Q, the length of tangent to a circle is 24 cm and the distance of Q from the center is 25 cm. The radius of the circle is, 4 options are given, A, B, C and D. So let's observe the question. In this question, we are having a circle with center as O and we are also having an external point Q. From this external point, we are having a tangent which is touching the circle at point T. So T is the point of contact for this tangent. Further, the length of the tangent is given as 24 cm. It means QT is given as 24 cm. The distance between the center and the external point, that is the distance between the point O and Q, is also given as 25 cm. And we have to find the radius of this circle, that is OT. Here we will apply the theorem 10.1. As per the theorem 10.1, the radius and the tangent are perpendicular to each other. The radius is OT and the tangent is QT. The angle between the radius and the tangent will be 90° angle. So this angle will be 90° angle. Further, if you observe, this is a triangle OQT. And this triangle is having one angle as 90° angle. The angle between the radius and the tangent is 90°. So we can say this triangle is a right angle triangle. And we know the property of a right angle triangle. We can apply the Pythagoras theorem. Let's apply the Pythagoras theorem. Here QO is the hypotenuse. Hypotenuse is the side which is opposite to 90° angle. So we got the hypotenuse. Let's apply the Pythagoras. 25 square is equal to 24 square plus OT square. Let's solve it. We got OT square is equal to 49. OT as root of 49, that is 7 cm. The option A is 7 cm. That is the answer. So the fundamental that we have used in solving this question is the theorem number 10.1. That is the angle between the radius and tangent is 90°. That is they are perpendicular to each other. And the second concept we have used is the Pythagoras theorem. So we have done with the question number 1. Let's move to question number 2. In figure 10.11, if TP and TQ are the two tangents to a circle with center O, so that angle POQ is equal to 110°, then angle PTQ is equal to. So this is the question. One figure is also given. Firstly, let's observe the given figure. In this figure, we are having a circle with the center as O and we are having an external point T from which we are having two tangents, the tangent TP and tangent TQ, and OP and OQ are the radius of this circle. One angle is given 110° and we have to find the angle PTQ, this angle. So let's approach the question. Here again we will use the same fundamental of the question number 1. The radius and the tangent are perpendicular to each other, theorem number 10.1. So the angle between the radius and tangent will be 90° angle. This is radius and this is tangent, so this angle will be 90°. Here also this is radius and this is tangent, so this angle will also be 90° angle. On observing, we are having a quadrilateral forming by joining the point O, Q, T and P. This is a quadrilateral. Three angles of the quadrilateral are given in the figure and we have to find the fourth missing angle. Simply we will use the property of the quadrilateral, that is angle sum property of the quadrilateral. The sum of all the four angles of the quadrilateral is equal to 360°. Three angles we know. Let's put the value. We got the missing angle as 70°. That is the answer of this question. The option B is 70°. So we have done with the question number 2. Let's move to question number 3. If tangent PA and PB from a point P to a circle with center O are inclined to each other at angle 80°, then angle POA is equal to, 4 options are given. Let's approach this question. This question is again talking about a circle with center as O. We are having a point P external to the circle. From the point P, we are having two tangents, PA and PB. Further in the question, it is also given the angle between the two tangent is 80 degree. So this angle is given as 80 degree. And we have to find the angle POA. For that, let's join AO, PO and BO. Here we have to find the angle POA, this angle. So let's approach the question. Here also we will start with the theorem 10.1, that is radius and tangent are perpendicular to each other. So this angle will be 90 degree angle. This is radius and this is tangent. So this angle will be 90 degree angle. Similarly, this is radius and this is tangent. So this angle will also be equal to 90 degree. Are you able to observe these two triangles in the figure? Can we say these two triangles are congruent to each other? Let's see. Here these two angles are 90 degree angle, means both of this angle will be equal to each other. These two sides are the radius of the circle. So OA and OB will be equal to each other as both are radius of the same circle. We got OA is equal to OB, the two sides as equal. Further, PA and PB, the two tangents will also be equal to each other. The theorem number 10.2, tangents from the external point will be equal to each other. So PA and PB are the two tangents from the external point P, so both will be equal to each other. So by SAS criteria, we can say both the triangles are congruent to each other. Once we got two triangles as congruent, all the angles and all the sides will be equal to each other. CPCT, the two congruent triangles are exactly copy paste of each other. So we can say these two angles, the corresponding angles will also be equal to each other. Angle APO is equal to angle BPO. CPCT, the corresponding part of congruent triangles are equal. Complete angle is given as 80 degree. Both the angles are equal. So we can say each angle will be equal to 40 degree. Moving further, if we observe this triangle only, we got two angles of this triangle. The third missing angle we are looking for, that is the part of the question. We know the sum property of the triangle, that is sum of three angles of a triangle is equal to 180 degree. We know two angles, let's put the value. We got the missing angle as 50 degree. That is the answer of the question. Got it? One important thing that you should note that these two triangles are congruent to each other. So these two angles are equal. This is very important concept and it will be repeated many times in various questions. So be prepared. These two triangles are congruent to each other. We can also join the point A and B. We can form the chord. These two triangles will also be congruent to each other and these two triangles will also be congruent to each other. So these angles will be equal, these angles will be equal, these sides will be equal. This is very important concept. You should know this and it will be helpful in solving many of the question. So we have done with the question number 3. The answer is A, 50 degree. Let's move to question number 4. Students, a small information. Download the formula and the concept list. The link is given in the description. You will also find the similar formula and the concept list for all the chapters for class 10th. Check out the link in the description. So again, back to the lecture. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. To prove the same, let's take a circle. AB is the diameter. Let's draw the tangent from the point A and also from the point B. We got two tangents. And in this question, we have to prove that both of these tangents will be parallel to each other. So this is the question. Let's take down this question. Now the question for you. How we can prove the two line segments as parallel to each other? What is the technique? The technique is the concept of the transversal. The transversal you must have covered in the previous classes. In the transversal, we are having two parallel lines which is cut by the transversal. Once we got the respective set of angles as equal, we can prove that the two line segments are parallel to each other. The same concept will also be applicable here. We will try to prove these angles, the alternate angles as equal. Once we have done that, we can show that the two tangents are parallel to each other. So let's see how we do that. Here also we will use the theorem 10.1. In the straight line, this is the fourth question where we are using the same concept. The radius and the tangent are perpendicular to each other. The angle between the radius and tangent is 90 degree. So this angle is 90 degree. Similarly, we can also use the same concept on the other tangent. So this angle is also 90 degree. Let's apply the concept of the transversal. Here these two tangents are the two lines which are cut by the transversal. So AB, the diameter, is the transversal. You can extend both the ends to clearly visualize the transversal. Now we can say these two angles are equal, that is the alternate angles are equal. So we can say once the alternate angles are equal, the two tangents are parallel to each other. That is the answer of the question. Tangent drawn at the end of the diameter of a circle are parallel to each other. Got it? We have done with the question number 4. Let's move to question number 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So this is the question. Let's take down this question. Let's have a circle with the center as O and tangent as PT. P is the point of contact. In this question, we have to prove that any perpendicular drawn from the point of contact passes through the center. So let's approach this question. Firstly, let's assume the point O dash anywhere inside the circle, and let's join O dash with P, and we will assume that O dash P is perpendicular to PT. Just we have assumed this new point O dash and we have joined O dash and P, and we have assumed the angle as 90 degree, that is perpendicular to the tangent. We have done this. As we proceed with the question, we will prove that point O and O dash or OP and O dash P is the same line. So this is the approach we will use to solve this question. Here O dash P is perpendicular to PT that we have taken. Further, as per the theorem 10.1, we know the radius and tangent are perpendicular to each other. It means OP and PT will be perpendicular to each other. This is as per the theorem 10.1. Here if we compare both of this equation, in the first equation O dash P is perpendicular to PT, and in the second equation OP is perpendicular to PT. Both O dash P and OP are perpendicular to PT. This can only be possible if OP and O dash P are the same line. If these two line segments are different and both are perpendicular to PT, that cannot be possible. That can only be possible if O dash P is on the other side of the line. Like here OP and O dash P are perpendicular to the tangent PT, but in our case O dash P and OP are on the same side of the tangent. So this can only be possible if OP and O dash P are coinciding with each other, basically overlapping with each other. It means that O dash is same as point O, that is the center of the circle. And that is the answer. The perpendicular at the point of contact passes through the center of the circle. That is the answer of the question. So students, we have done with this lecture. If you have enjoyed, like and subscribe to our YouTube channel, and also share this video with your friends and the class 10 student. We also have a similar kind of video, all the chapters for class 10 student. Check the playlist section of our YouTube channel. And best of luck for the exam you are preparing for, and have a great day. Bye for now.